Namaste everyone, hope all of you are well. Today we are going to discuss lecture number 3, Equilibrium, chapter number 7, class 11. So here in the previous video we have discussed about the stoichiometric reactions and how to write. Especially I have discussed about the stoichiometric reactions, that how to write. As if I talk about that in the previous video, the last reaction was NO2, right? This NO2 converts into, this is a chemical reaction, 2O2. So that will be total 4 oxygen, right? 2 nitrogen and 4 oxygen. So this is a chemical reaction, a chemical equilibrium reaction. If I'll ask you to write the concentration of this chemical equilibrium in the stoichiometric reaction, then you can write here as concentration constant is equal to the product of nitrogen, means concentration of nitrogen and oxygen to the power 2 upon NO2 to the power 2. So this is a chemical equilibrium constant, or you can say the concentration constant also. And in this reaction only, the same reaction here, 2NO2 N2 plus 2O2. If we divide this reaction by 2, so what will be here? NO2 half N2 and plus O2, right? Here what we have done, we have divided the reaction by 2. After dividing the reaction by 2, the same thing here we have got it. You can see here this reaction, and then what will happen? There no problem, just multiply by 2. So it will become 4NO2. Here it will be 2N2 plus 4O2, right? And here the equilibrium constant will be N2 to the power 2 oxygen to the power 4 upon NO2 to the power 4. So this is the equilibrium constant, right? You can write this or not? Definitely you can write it. So the two equilibrium constant, if anybody will ask you here, earlier the constant reaction here and here, what is the relation between these two? Then you can directly say here that the equilibrium constant is related here, that here it is just multiply Kc. Just suppose here this is Kc and this is Kc1. So Kc1 is the square of Kc, right? Right. Kc1 is the square of Kc, that is equilibrium constant. Here just I have put in dash. So if anybody will ask you that what is the relation, then you can write here equilibrium constant is equal to equilibrium constant, or you can write C1 to the power n. So this is the relation between the equilibrium constant. Whatever the coefficient term comes, you can multiply these coefficient terms and you can show the relation, that what are the relation between these, right? Now the main thing, as I have taught you in the previous video, in the lecture number 2, that what today we are going to discuss, that is degree of dissociation. Very, very important term, the degree of dissociation. What is the meaning of this degree of dissociation? You know, the value of equilibrium constant and depends only on temperature. That is degree of dissociation. It is the fraction of moles of reactant dissociated. Fractions of mole. It is the fractions of moles of reactant dissociated. So let's start our new topic, that is degree of dissociation. Our new topic is degree of dissociation. Means how the reactant is being dissociated in the product, and what are the terms, fractions of moles and dissociated. Just suppose here that A plus B, these are the reactants, and C plus T is the product. If anybody will ask you here, what is the number of moles of reactant? If the fraction of moles of reactant dissociated is, if I ask you that, what is this dissociation of, here just suppose that this is degree of dissociation. If I talk about, then directly understand that alpha is equal to x by a. This is the degree of dissociation. The reactant side and product side, whatever the terms we are taking. If just suppose here, as the time has taken to dissociate it, here it was x, it became a as the time has taken to dissociate. So here, that's why I have written here that if the fraction of moles of reactant dissociation is x by a, then the percentage of degree dissociation, if I talk about, what is the percentage of this degree dissociation? But the x by a into 100, right? So if anybody will ask you, what is this x, a, alpha, what is this? This alpha is degree of dissociation, x is the number of dissociated molecules, and a is the initial number of moles. What is that? A is the initial number of moles. So here, degree of dissociation what is that? Alpha is degree of dissociation, alpha is initial number of moles, and x is the number of moles, number of dissociated moles. X is number of dissociated moles. Means how many moles has been dissociated, and what is the value of A? A is the initial number of moles. Means whatever it was given, initial number of moles. So here the degree of dissociation, just suppose the initial number of moles was A and the number of degree dissociation has been x. So here the degree of dissociation will be x by A, and the percentage of degree dissociation will be x by A into 100. Now, what is the applications of law of mass action? The relation of dissociation with the volume and pressure, if I talk about in the homogeneous gaseous reactions, means when the delta Ng was 0, that time, as we have used also these terms in the previously, just suppose I am taking one reaction to express the constant term, that how this reaction. So if you want to take a click of this, that what is this degree of dissociation, you can take a click, but later on I am giving you an example. According to that example, we will discuss that how this degree of dissociation we are working at the terms of constant. Okay? Hydrogen iodide. How this hydrogen iodide is formed, you know very well that when hydrogen is treated with iodine, it gives hydrogen iodide, right? So here how to express, just suppose this is the hydrogen gas, this is the iodine gas, and it gives you hydrogen iodide. What it gives you? Hydrogen iodide. So in this chemical reaction, if I talk about the reactant molecules, just suppose if the reactant molecule is A, here B, and this is 0 at the initial, this is at the initial molecules. Okay, after changing, as the dissociation phenomenon has been occurred, so what will be here? X minus A, here X minus B, and here 2x. Got it? At the initially, the hydrogen molecules, the reactant concentration was A, iodine concentration B, and the hydrogen iodide was not formed, since I am talking about this degree of dissociation. So if I talk about the homogeneous gaseous reactions, and if I talk about the expression constant, then initial molecule and the molecule's moles at equilibrium. Let us start with moles hydrogen and iodine. Hydrogen was A and iodine was B in a closed bulk of V volume at the equilibrium X molecules of each, hydrogen and iodine, which have reacted and given the 2X molecules of hydrogen iodide. Right? So that if I talk about what will be the volume of hydrogen. So if I talk about the volume of hydrogen, so here the volume of hydrogen H2 will be X minus A by V. If I talk about the volume of iodine, it will be X minus B by V. And if I talk about the volume of hydrogen iodide, then what will be? Can you tell me? It's very easy. It's 2X by V. So here as you have seen that, so it will be 2X by V. What you have seen here, as you have seen that, what are the active masses of this hydrogen iodine and hydrogen iodide, right? Now after applying the law of mass action, apply the law of mass action. What will be the law of mass action? If I talk about that constant term, then the equilibrium constant will be, so here you can see here there is 2 hydrogen iodide in the product side, so hydrogen iodide to the power 2 upon hydrogen and iodine. Yes, this will be that. And if I talk about their volume, that active masses, then what will be the formula? Can you tell me? So here see in the form of hydrogen iodine, what we will write here? 2X by V to the power 2 upon hydrogen is X minus A by V, and here X minus B by V, right? So here you can see 4X square upon V square into V square upon X minus A into X minus B, V square cancel, 4X square upon X minus A into X minus B. Yes? So here the equilibrium constant for the volume, as you can see here, right? Can we write this term or not? Can we that? Definitely we can write it as what I have done here. The hydrogen and iodine I have taken. The initial molecules was AB. Here after the T times the volume, here it became X minus A, X minus B, and here the 2X. So the concentrations at the active mass, as you have seen here, what will be the equilibrium constant? 4X square upon A minus X into B minus X. Right? Oh, sorry, one thing I have done from A minus X, here it will be, right? Correct. A minus X, and here it will be A minus B minus X, because in the reactant side whatever the number of molecules has been dissociated, so that time that here it has to be, right? So no need to worry. A minus X and here B minus X. So here A minus X and here B minus X. A minus X and here B minus X. Okay? So the concentration constant will be 4X square A minus X into B minus X. Got it? Understand everyone? After understanding this concept, if I put the value of A and B is equal to 1 and X becomes the degree of formation, then hydrogen iodide or degree of dissociation of the hydrogen and iodine, what will be the value of that Kc if A and B becomes 1? Just suppose that here in this term Kc is equal to 4X square upon A minus X into A minus B. Sorry, B minus X, not A minus B, B minus X. Right. And if I put here, if the value of A is also 1 and B is also 1, so what will be the value of concentration constant? 4x square 1 minus x into 1 minus x. So can we write here 4x square upon 1 minus x whole square? Can we write this? Yes or no? Definitely we can write. Yes? So can you tell me that the value of x will be less than 1 or greater than 1? If x is less than or very much less than 1, then what will be the value? If x is very much less than 1, then 1 minus x is equal to 1. Right? So what will be the value of constant? If it is 1, then Kc will be 4x. 4x upon 1 square. So Kc will be 4x square, not 4x. It will be 4x square. Right? So here, if I talk about x square is equal to Kc upon 4. So x will be under root equilibrium constant upon 4. Right? And if you want to remove this equilibrium constant, then here you can write the degree of dissociation. X is directly proportional to the water. So that's why here what I can write, x is directly proportional to the water. Okay? So here, as you have seen, what is the degree of dissociation. Now after understanding this equilibrium constant, if we take at the pressure constant, what will be the value? Nothing is going to change. Instead of x, we are going to take a p. So a minus x upon a plus b into p. That will be partial pressure, and the partial pressure of iodine will be b minus x by a plus b into p, and the partial pressure of hydrogen iodide will be 2x upon a plus b into p. There is nothing else. So instead of that Kc, we have to just take a Kp at a constant pressure. I hope all of you have understand this concept. Now we are going to do these things with the another reactions, that is PCl5. Okay, in the homogeneous, that was in the heterogeneous. Now we are going to do in the homogeneous. Phosphorus pentachloride. Phosphorus pentachloride. PCl5 gives PCl3 plus Cl. Okay, this is our homogeneous reaction. Now, if I talk about the degree of dissociation, at the initially this was A, reactant, this is 0, 0. Now this product was X, right? PCl3, if I take and say reactant and product has been changed. So if I talk about here, this is also X and this is also X, so this will be A minus X, right? Degree of dissociation. Now if we talk about the volume of PCl5, what is the volume of PCl5? No need to worry, dude. So the volume of PCl5 volume is equal to A minus X by V, right? The volume of PCl5 is A minus X by V. And what will be the volume of PCl3? It will be X by V. And what is the volume of Cl2? It will be also X by V, right? So as you have seen here the volumes, now apply the concentration constant. So the concentration constant Kc is equal to product is PCl3, concentration of PCl3 and concentration of Cl2 upon the concentration of PCl5. Now what are the volumes? PCl3 volume is X by V into X by V upon A minus X by V. Right? So here X square by V square into V by A minus X, we cancel. So here X upon A minus X into V. Right? What will be the value of equilibrium constant? X square upon A minus X into V. X square upon A minus X into V. Right? Now, if I talk about it, the value of A is 1. Right? Similarly, as we have done earlier, if we talk about that when equilibrium constant is X square upon A minus X into V, if A is equal to 1, then the equilibrium constant X square 1 minus X into V, right? This will be the value of equilibrium constant. But if A is less than 1, or you can say if A is less than 1, then what you can say? 1 minus X is equal to 1, right? Can you see or not? Tell me that 1 minus A is equal to 1. If 1 minus A is equal to 1, then what will be the value? The value will be Kc is equal to, here just suppose Kc is equal to X square upon 1 into V, or Kc is equal to X square upon V. So this will be the equilibrium constant value, right? So you can say here that the degree of dissociation constant is directly proportional to the square root of volume. Degree of dissociation constant X square is equal to directly proportional to V, so X is directly proportional to under root V, right? So here you have seen that degree of dissociation constant of volume in the homogeneous and heterogeneous reactions, that how it is being expanded. Just going through the ahead that how to calculate. Similarly in the constant pressure, these are all the things as we have seen in the reaction, that how to write. So the things we have learned is, I am saying you the things which we have learned in the inert mix, constant temperature and constant volume in an equilibrium chemical reaction, the total number of moles of gases are present in the container increases as the total pressure of the gas increases, but the concentration in the terms of mole per liter, and the partial pressure of reacting substances are unreached, so the degree of dissociation unchanged. Now this was the main concept, that whatever I want to teach, now we'll go through the NCERT, the law of mass action applied in the degree of dissociation. So as we have seen in the homogeneous and heterogeneous, that how the degree of dissociation has been changed and how does it reacts, right? So this thing is the main concept whenever you learn to write. See, if you don't know how to write, as I have told you about in the reactions, that A plus B, and I have shown you this was the rate of reaction, that was C plus D, and I have told you whatever the coefficient term you can take here, M1, M2, N1, N2, and I have told you that if you want to write the equilibrium constant, then I have said you the equilibrium constant is equal to the concentration of product, right, upon the concentration of reactant. Have you remembered this word? According to this only we are following everything. This was the concentration constant, and we have taken the each and every reaction will follow the same thing, as I will show you what is the first rate law of reactions, second rate, third rate. I will show you everything. Let's go one by one. Law of mass dissociation as applied to the heterogeneous equilibrium. Just suppose I am giving you one reaction. Calcium carbonate convert into calcium oxide and carbon dioxide. Okay, calcium carbonate. So here I am taking you the dissociation of calcium carbonate in a closed vessel, that is calcium carbonate CaCO3 equilibrium reaction, calcium oxide plus carbon dioxide. If we want to write the physical state terms, then solid gas. Calcium carbonate is the solid, calcium oxide is also solid, carbon dioxide is in the form of gas. Now equilibrium constant at the pressure Kp. So what will be the formula of Kp here? Kp will be, the pressure will be applied only and only in the carbon dioxide. Kp is equal to P CO2. Got it? Now if I talk about water, okay, take water, H2. 2H2O gives, can you tell me how the water will be dissociated? H2 into O2, right? Now can you tell me here what will be the terms of Kp? Kp will be nothing else, just same as your carbon dioxide was single. Here the hydrogen is 2 molecules, right? So here hydrogen 2 molecules, P of H2 is equal to 2 molecules and oxygen 1 molecules, right? Correct? Now if I talk about iron with water, 3Fe plus 4H2, 3Fe plus 4H2, what it will gives you? Fe2O3 plus H2, Fe3O3 plus H2, right? If you want to write these are all the things in the don't forget to write these all things, okay? So what you have seen here, that iron plus water, ferric oxide plus hydrogen gas. Now you have to balance this reaction. No need to do anything, just see here 4 2 8. So 4 2 8, everything is balanced, right? Fe3O4 will be there, don't worry. Here reaction will be Fe3O4, ferric oxide, Fe2O3. Here you can write like this, Fe2O3 and FeO. This is called ferric oxide, so Fe3O4, okay? Now if I talk about the concentration, so what will be the equilibrium constant at pressure? Very easy, can you tell me? The equilibrium constant at pressure will be Kp is equal to hydrogen to the power 4 upon water to the power 4, right? So at a constant pressure only the gaseous molecules. Now in the next video we will discuss about the Lecture-3 principle for the chemical equilibrium, the change in concentration, and whatever the things you are learning, don't try to forget it. Try to write into the notebooks, whatever the things you are learning. Either you are learning anything in the equilibrium, in anything in the thermodynamics, whatever the things you are learning, if you are not able to understand, first see from the previous video, that lecture number 1, lecture number 2, whatever I had explained, you have understood that concept or not. If you are not able to understand that concept, then try to write your doubts and then drop that doubt into the comment box section. In the next video, definitely I'll make your all the doubts clear. That's all for today. Thank you very much. Have a nice day.